Hello, my name is Abraham Mofori, and in this video, I will take you through exponential equations. So let's start. Definition. So exponential equation is an equation that involves equating the exponents of both sides of the equation when the base of the exponents are the same on both sides. You see, both and equations are occurring here. All right, so let me write an example and I'll use it to explain. Okay, so example is if I have So exponential equation is an equation that involves equating the exponent of both sides of the equation. So if I have an equation like this, then I'm supposed to equate the the exponents here of both sides of the equation when the base of the exponents are the same on both sides. So it means the bases here on both sides should be the same, and it should stand single like this before I can equate them. Okay, before I can equate this power to this power, then I need to make sure that this is single here, that's a to the power something, single here, nothing is attached to it, or plus nothing is here. And this is also a to the power something like this. I mean, everything should be single before you can equate the tops or the exponents. Okay, so this implies that 3x equals 2q. So from this statement, this is what it means. So it means that if I have something like a to the power 3x equals a to the power 2q, then I can equate the powers. Okay, so let's solve some examples before you can understand deeply what I mean. Okay, all right, so the first one is you are supposed to solve for x from this equation. 3 to the power x equals 3 to the power the expression 5x minus 4. Okay, since the bases here are the same on both sides and a single raising to the power something, I can equate the powers. Okay, so solution, if this is given, then this implies that what x here is equal to 5x minus 4 from exponential equation. Then this is, I just do simple computation. That is, I take the x's at one side, then I group the numbers at one side. So x minus 5x equals negative 4. Now I have negative, this minus this is negative 4x equals negative 4, and this will give me what x equals what 1. Very simple, right? Okay, so let's continue. So you are supposed to solve for x in the second equation, where I have 2 to the power x equals 4 to the power x minus 1. So here, before we said that before you can equate the powers, you have to make sure that what the bases here, if you don't understand the bases and powers, I've done introduction to indices. Okay, you can go and watch it and solve the examples that I did in the video, and then you can understand bases and powers. Okay, so 2 to the power x here equals that. I have to make sure that the bases are the same. What is 4? 4 can be rewritten as what? 2 times 2. Okay, so if I'm given this, I can write 4 as what? 2 times 2 all to the power of x minus 1, and 2 times 2 is what? 2 squared. Now from our rules of indices, we said if you have a to the power m all to the power n, then you can multiply the two powers. Okay, so same thing applies to here. Then I can rewrite this as 2 to the power 2 times the powers here. I hope this is clear, right? We are using the identities in indices. Okay, now since this side, the base here and the base here are the same, and then they are single standing, then I can equate the powers. Okay, so x equals what? 2 times x minus 1, and then I expand this side and solve for my x. X minus 2x equals negative 2, and now my negative x equals negative 2, and then x, this implies that x is equal to 2, because if I divide both sides by negative 1, I'll get x equals 2. You see, this is very simple, right? Okay, let's continue. So we are supposed to solve for x in this. Okay, here we can do it in two ways. This side is containing 4 to the power something, this side is containing 8 to the power something. I can decide to maintain this in 4 and change the a to what? 4, but it won't work because 8 cannot be rewritten in terms of 4 times itself. Okay, we can't write 8 as an index power of what? 4. So all that we have is to make sure that here we can change a to an index power of what? 2. can change 4 also to an index power of 2, so that both sides has the same what indices. So if I'm given this, the first thing I'm supposed to do is what, um whoa, there's a mistake here, but I hope you can see that. You have to make sure that you reciprocate this side. Okay, so reciprocate this, I get a negative of whatever that is here. So if you remember, in our indices, we said if I have 1 over a to the power n is the same as a to the power negative n. The n is not necessarily going to be just a single index. It can be an expression like this. So the negative of all of them. So since here there is a mistake here, okay, 4 was supposed to be like 2 times 2. That is why I wrote 2 square here, okay. So it's supposed to be like 2 times 2 here, all to the power 5 minus 9x, because that's okay. Then 2 times 2 give me what, 2 squared. And 8 is what? 8 is the same as 2 times 2, which is 4, times 2, which is 8. All to the negative what? 3x plus 2. And now I can rewrite this as a 2 to the power 2 times the whole of this from indices. And this is the same as 2 to the power 3 times what? Negative 3x plus 2. Negative of the expression 3x plus 2. And now, since both sides have the same basis, I can equate the power. So 2 into bracket 5 minus 9x equals 3 into bracket negative of the expression 3x plus 2. Now, 2 times 5 is 10. 2 times negative 9 is negative 18x. And 3 times here, the negative, if it affects the bracket here, it will give us negative 3x, negative 2. So 3 times negative 3x, I get negative 9x. 3 times negative 2 will give me what, negative 6. Okay, so this implies I have something like negative 18x plus 9x equals what, negative 6 minus 10. Here I just sent this negative 9x here to this side and sent the 10 to this side. That is how you get this. This implies I have what, if I add this and this, negative 18x plus 9x, I get what, negative 9x. And this will give me what, if I negative 6 minus 10 will give me negative 16. So I get x equals 16 over 9. Okay, so this is very simple, right? So you can go on further and then change this to mixed fraction if you want, but I left it like this. Okay, now we are supposed to solve a complex exponential equation. If you can see all of these, you see, we were able to make sure that the basis here is the same as the base here and they stand single. But look at the next question. It's like this. We have 3 to the power x plus 3 plus 6 times 3 to the power x plus 1 equals 81. Here there is an addition operating sign here. So how do you go about it? Given this, we make sure that we change this side to a 3 times something, because if you can say that this is the same as 3 to the power x plus 3, then this is the same as 3 to the power x times 3 to the power 3. This will give me this. And same thing applies to this side. This will also give me that. And it's equal to 81. So now, look at this. Since we have some 6, 81, and 3 inside this, okay, let's continue and see. 3 to the power 3 is what, 9. Multiplication is what, commutative, and I can interchange wherever I want to put my first one. I can put the first item here, multiply it by this. It doesn't change anything. Same thing here. I can put this 3 here and change the 3 to the power x here. It doesn't change anything. So now, since 3 to the power x is inside and we don't know how to solve this equation, we let y, a certain variable y, be equal to what? 3 to the power x. Now, if y is equal to 3 to the power x, wherever you see 3 to the power x, you put in y. It becomes 9y plus 18y equals what? 81. Now, you have 27y equals 81, and then we divide both sides by what? 27. Then we get y is equal to what? 3. But you are saying that y is equal to what? 3 to the power x. This means that this our y here, 3, is equal to what? 3 to the power x. Because the y that we calculated for wasn't what we were supposed to find. We were supposed to find x. And now we are saying that y is equal to what? 3 to the power x. So after finding your y, come and substitute your y into this equation to get what? 3 to the power 1 is equal to what? 3 to the power x. Now in indices, here is 1, here is to the power 1. Okay, so from exponential equation, we can equate the powers. So 1 is equal to x. This implies that our x is what? 1. I hope this is very cool, right? Okay, so let's continue. So the last one that you're supposed to solve for today is that you're supposed to simplify this using exponential equations. So how do you go about this? Okay, think about this more. So know that the reason why you want to maintain or change e to the power x and make it stand alone is that we can easily replace e to the power x by something and solve. But here there is an e to the power 2x. But we can change this to e to the power x to the power something. Okay, since we know how to manipulate indices. Okay, so this is the same as e to the power x to the power 2. Since in indices, if I have e to the power mn, I can write it as what? E to the power m or to the power what? N. Same thing applies to here. So I change this to e to the power x or to the power 2 and write the same thing. Alright, then I'll let my y be equal to what? E to the power x. Now if I put in y, wherever I see e to the power x, I put in y, then I'll get what? Negative 2y squared minus 4y plus 6 equals 0. Then I have to solve this. This becomes what? A quadratic equation, but I can divide through by what? Negative 2. And I'll get what? Y squared plus 2y minus 3 equals 0. So if I divide here by negative 2, I get y squared. This by negative 2, I get what? 2, because negative 2, negative will cancel negative, then 2 goes into 4, 2. The negative 2 goes into this what? 3, but you have a negative, so it becomes negative 3. Alright. So now solving this quadratic equation, from how you know quadratic equation, you just multiply the coefficient of this side, which is 1, by this, which is negative 3, and you find the factors that when you multiply, you get what? Negative 3. But when you add, you get what? This number 2. So you actually treat quadratic equations, so don't worry. So this, we just, after finding them, is what? Negative 1 and 3. That when you add, you get 2. But when you multiply, you get negative 3. So you make sure that you divide it and write it like this. Okay, that this becomes y squared minus y plus 3y minus 3 equals 0. So looking at here, it's like after adding this and this, you get back this. So you've not changed anything in this. Okay, so I can group some terms here and try to factorize some things out. So here I can factorize my y out. It becomes y minus 1 plus 3 out y minus 1. If I factor y here, I'll be left with what? Y, because y times y will give me y squared. And here becomes minus 1. Y times minus 1 will give me minus y. Then here, if I factor 3 out, I'll get what? Y here minus, I'll be left with 1 here. So this implies that y minus 1 here, there's y minus 1, y minus 1 here. So I can factor it out. And I'll be left with y here plus and 3 here. Then equal to 0. This implies that y minus 1 is equal to 0. And this will give me y equals what? 1. Or y plus 3 equals 0. And this will give me y equals what? Negative 3. Now you've gotten two values for y. So you need to test for all of them, the two of them, using this equation. So y is not what we want. We want x. But here y is representing what? E to the power x. And so I have to find a way of solving for my x. So y is 1 or y is negative 3. Then, but we are saying that e to the power x is y, or y is equal to e to the power x. So if that's the case, when y equals 1, e to the power x is what? 1. So we are saying e to the power x is equal to y. Then, but we know that any number to the power 0 is 1. So it means that this is actually the same as e to the power 0. And so from exponential equations, since the base here is e, the base here is e, I can equate the powers and say that x is equal to 0. Right? So from the first scenario, when y equals 1, x is equal to 0. When y equals negative 3, you have e to the power x equals negative 3. And this we can't solve it because there is no, what do you call it, number that, there is no the same base here. And we could have applied something like we call logarithm, but there is no logarithm of a negative number that exists in this world. So You can't solve it and then you just leave it like that. Okay. Hence s equals 0, the solvable parts. So but what if the bases are not the same? Okay, we are just in this, since we are dealing with exponential equation, we are dealing with exponential equation whereby the size, the bases on both sides are what, the same. But what happens when the bases are not the same? Okay, something like 5 to the power s equals 9. Then we use what we call logarithms. So in our next video, we talk about logarithms. So thank you, and please subscribe to my channel for more videos and share it as well. Okay, so see you next time.